Okay, we are now ready for section 5.5. And so this again will be in two parts because I have not really taught you the meaning behind integration, and I'm going to do that next week. But so you got to just go with this. We're learning the how to do stuff, the plug and chug. We're getting good at this, and then we'll apply meaning to it so that we won't have to try to figure out how to do it while we're trying to learn what it means. So this is part one, and we'll revisit this again, so just be aware of that. Okay, substitution rule is a technique of integration, and so it's very handy, and we use it a lot, and so it's really good. And so at the top of your worksheet, I have it printed out. It says, if u is equal to g of x is differentiable, is a differentiable function whose range is an interval I, and f is continuous on I, then the integral of f of g of x times g prime of x dx times its derivative can be rewritten as to it's equivalent to the integral of f of u du. We can rewrite it in terms of u, where u is g of x and du is the derivative of g of x, and so this would be g prime of x dx. So this doesn't make a whole lot of sense, but it will in just a few minutes. I'm going to do some examples. This is the best way to really learn this is just by doing some examples. So I'm just going to show you this. We're going to do it for an indefinite integral with the plus c, and then we're going to do it with a definite integral. So when we change it in terms of u, there's a little thing we have to do with the limits. So here we go. Example 1 through 5 are indefinite integrals. So the first one is this. It says, let's integrate the sine of the square root of x over the square root of x. So this looks kind of hard to do, but once we learn about this little technique, it becomes pretty easy. You introduce this new variable, you will say, well, let's let u equal to something that looks kind of complicated in here. So at first you're just guessing because you've never done it before, but then later you get a feel for how it goes and you realize you're looking to let u be something whose derivative you can see somewhere in here. Let u be something whose derivative you can see somewhere in here. So this might not be immediately obvious, but you can kind of take a few guesses at first. I'm going to let u equal to the square root of x. So that is also x to the 1/2, right? So then when I take the du, which is the derivative of u, that's equal to 1/2 x to the negative 1/2, which is 1 over 2 times the square root of x, when I write it in this notation. So let's see, is this helpful to integrate this? Yes, it is. If I were, and this is dx, I forgot my dx, that's important, times dx. So what I want to do is rewrite this integral in terms of u. What I need to do that is to rewrite the x's in terms of u. And what I see here is if I have du is equal to 1 over 2 square root of x dx. If I want this to be 1 over x dx, and I do, because when I look here, if I rewrite this as the sine of the square root of x times 1 over the square root of x dx, that might be helpful for you to see. I won't do this every time, but I want you to see exactly what's happening here. 1 over the square root of x dx is right here. Only that 2's in the way, but constants are not that big a deal. Multiply both sides of this equation by 2. And then I have this. So that is very helpful. What I have, let's see. I need to rewrite this integral in terms of u. So 1 over the square root of x dx is the same thing as 2 du. This part is taken care of. How can I rewrite the sine of square root of x? I have to rewrite that in terms of u. Well, u is the square root of x. So this can be rewritten in terms of u. The green marker, I have a hard time erasing, so I'm going to go for purple. In terms of u, this is going to be the integral of the sine of square root of x is u, okay? And then I need 1 over x dx times 1 over x dx. 1 over x dx is the same thing as 2 du. I'm going to tack the little du on there, and I'm going to go ahead and put the 2 in front. Excuse me. Now I just integrate this with respect to u. What is the integral of sine? What can I take the derivative of and get sine? Well, the derivative of cosine is negative sine, so I need to integrate and pop that negative on there. Negative 2 cosine of u plus a constant. The last step is to rewrite u in terms of x. So this is negative 2 cosine of, I have to rewrite u in terms of x, and so that is, what did I let u be? Square root of x. That's the very last step right there. Cosine of square root of x plus a constant. So that's my final answer right there. So that is one illustration of substitution. There are many more we're going to do, but it'll go a little faster. You'll get a feel for how it goes. Because when you look at number 2, wow, that looks so terribly complicated. What in the world am I going to do with that? They asked me to integrate the sine of x times the sine of the cosine of x dx. So I have to integrate this. And u substitution is just another tool in your math toolbox that works many times, and so I'm going to try to use it here. It's not guaranteed to work every time, but it's something that we're like, hey, maybe this will help us out. So let's try this out. Let me see. You could just guess a little bit. You might let u equal to the sine of x and see what happens. You might let u equal to the cosine of x and see what happens. So when you're first doing this, you don't automatically know what to let it equal, but it helps if you're looking in mind. What I want to see in here is a derivative of something. See, I want to be able to see just a clean derivative. So if I think about it, the sine, the derivative of cosine is negative sine, and I do see a sine there. I'm going to give this a shot and see where it leads me. So let's see. Let's let u equal to the cosine of x. See what happens. All right, well then du would equal to, take the derivative of this, then du would equal to negative the sine of x dx. And so what I need to rewrite this, I definitely need a sine x dx, and I can get that by dividing both sides by a -1. Negative du would be the sine of x dx. Then that leaves me with this. Can I rewrite the rest of this in terms of u? Well, sine is a function, so that would be the sine of cosine of x is what I decided to name u, so that's going to work. It cleans it up so nicely. So let's see. We've got negative du. If I write that down, the integral, just write your integral. That's free. That's a free one. Just write your integral symbol down. Negative du. What did that take care of? That took care of sine and dx, and we got the integral symbol. What's left to rewrite this function? The sine of the cosine of x. So the sine, I let u be the cosine of x, so it's the sine of u. What can I take the derivative of and get sine x? Or even in this case, it's helpful to think of this as negative sine x. What can I take the derivative of and get negative sine x? Cosine of x. So the integral of this is going to be the cosine of u plus a constant. So the last thing I have to do is replace u with what I let it be right here. So the answer is going to be the cosine, not of u, but of what I let u be, and that was the cosine of x. The cosine of x plus a constant. So that right there is number 2. All right, let's do 3, and you're going to really get the feel for it. And I'll make this 2 videos so that it doesn't, so you guys can have a little bit of a break. I know you can always hit the stop button, and that's not that big of a deal, but it probably some of y'all wouldn't. You'd probably just be like, let's just finish this while we're at it. So it'd probably be good to have just a little breather. So, all right, so let's do number 4, and then we'll take a break. Well, I'll stop the video and make another one. Okay. So number 4. If we were in the classroom, if we were face-to-face, we'll do this and then we'll go take a 10-minute break. So that's what we do in the classroom, face-to-face. So maybe you should do that in real life after number 4. The integral of the sine x over 1 plus cosine squared of x dx. So we have sines and cosines. And so what we're looking for is to let u be something whose derivative we see here. So when you're thinking about this, kind of the choices are sine or cosine. That's what's popping into my mind. What could I let u be? If I let u be cosine, the derivative of cosine is negative sine, and I could fix that with that negative is no problem. That would be good. What if I let u be sine? Well, the derivative of sine is cosine. Okay, let's try that. Let's see what would happen. Because you don't know what to let things be at first. Let's let u be sine and see what happens. Okay, well then du would be the cosine of x dx. So we definitely see some cosines, but I don't just see cosine of x dx sitting there. I see it down here, wrapped up here. So really this would be 1 plus du squared. That is getting weird and crazy, and I've never seen anything like that, and that gives me a bad feeling, and it should give you a bad feeling too. So that's not the route we want to go. Let's try a different route. So let's let u be cosine of x and see what happens here. So let's let u be cosine of x and see if that does anything better for us. Du would be negative sine x dx. And I see sine x dx right there. That's looking better. The question is, could I rewrite the rest of it in terms of u? And I could. So this is what's going to happen. I need sine x dx, not negative sine x dx. So if I divide both sides by negative 1, then that's what I get. So I get that. So that's good. The negative, remember the integration symbol is free. Negative du gives me this. And then I need to rewrite. What I have basically left is 1 over 1 plus the cosine squared of x. That's what I have to rewrite. But I let u be cosine of x. So this is really 1 over 1 plus u squared du. And I recognize this, and if you look at your table of integration that we just created a little while ago, you will recognize this too. This is the inverse tangent of u. So once we integrate this, this is negative tangent inverse of u plus a constant. And the very last thing to do is rewrite u as what we defined it to be of the cosine of x. And this is your answer to number 4. So now I'm going to stop this video. Y'all take a short break or a long break or whatever, and then you can look at the second video where we finish this worksheet.